a very good morning to all of you joining this webinar on innovation funding for net zero goals. My name is Patricia. I'm BCF Sustainability Manager, and well, this is just part of the various webinars and seminars the BCF is organising on sustainability topics. Key sustainability topics, one of them being innovation funding. So we've got colleagues from Think Incentives this morning. They'll be talking you through a presentation. So that's going to be led by James Norton. And then we will also have colleagues from IPG, again, leading by Toby. And then, yeah, they'll be running through a very short presentation as well to show you an example of their technology. There will be opportunity for Q&A towards the end. So if you do have any questions, you'll have the chance to ask those to either James or Toby or myself or whoever really. And of course, we'll be happy to take any questions offline as well via phone or email. Whatever is easier for you. So without delay, I think I'll just hand over to James now. Yeah, welcome and hope you find this webinar useful. Thank you.
Right, so let's get on with this. Many thanks, firstly, Patricia and Belle, for arranging the session. Very kind of you, and it's a pleasure to do what is our first session, actually, online webinar for BCF. So thanks very much for joining the session this morning. Innovation funding for net zero goals, but there'll be a focus on the currently open Industrial Energy Transformation Fund grant funding program, which is going to be of interest to most of you as participants. Just to describe a little bit more about us, so as Think Incentives, we're business consultants. We specialise in innovation-focused funding, incentives, and linked strategy. And of course, we are, as Patricia mentioned, an associate member of the BCF. Critically, we also deal with the interactions between those different incentives regimes and the threats and opportunities and sort of best practices. So it's an overall sort of holistic view of the innovation funding and incentives landscape and how it all works together, basically. Some of you may have seen us last November at the Road to Net Zero seminar, hopefully. Some of those same themes are coming through in this session today. So just in terms of who we are, I'm James. Obviously, this is George, and I'm not sure if you can see Amir just off screen at the moment. But we're all very strong in sort of science and engineering backgrounds. That's our origination. We come from industrial science and engineering backgrounds, but we also come from a consultancy background as well. I also trained on the IP side as a patent attorney and barrister, so we covered sort of intellectual property that's linked to the incentives and funding that we cover. We support businesses with training, advice, and services which are linked to these incentives regime, all of those things which drive funding, innovation, and supporting innovation projects. So just turning to the next slide. George?
Right, I'll do the boring commercial bit. So thanks, James. So obviously, James mentioned we're specialist business consultants and we specialize in innovation funding. But what I think is pretty relevant for us to give you an idea of all the things that we cover and why it's relevant and why we're talking about the IETF specifically, and also some of the other things that will particularly be relevant if you are engaging in some sort of innovation or R&D in the future. So if you look at the innovation lifecycle, you can start with grant funding. And within grant funding, we offer everything from grant identification, consortium building, application, drafting, review, grant management, grant reporting, and also specifically grant strategy. There are a lot of grants out there that you can and should, and there are also the grants that you potentially should and shouldn't be going for after as well. And also the interaction between grants and some of the other incentives specifically around innovation as well. So there's a lot of strategy that needs to be considered there. Next, hopefully, you've got some money to innovate. You'll also be spending some of your own money. And with that money, you should definitely be making use of R&D tax credits. So whether you're a large or a small company, this is obviously a very well-established form of innovation incentive that the government has imposed. Lots of changes. And again, that's been going on in the past couple of years, but also something that every single company should at least consider applying for, because in real terms, it's also potentially grant funding as well. So again, we help with R&D claim preparation. We offer a lot of education and advice around this, because obviously it can be a very complex area full of HMRC inquiries and I guess hurdles and places where people can trip over in putting together a claim. And we also do full claim preparation for some of the bigger clients as well. Next, hopefully you spent lots of money and time and effort on innovation. You would have generated some sort of intellectual property. And again, this is where we deal with a lot of IP strategy and advice. We help our clients do a lot of patent applications through our network of patent attorneys. We do a lot of our other intellectual property related stuff, such as trademarks and also various other types of design rights. We also deal with a lot of patent box incentives. So these are tax incentives associated with innovation and IP and patents. And also we engage in support for IP disputes and litigation as well. Some of the other things that kind of link to innovation is also partnerships. So again, we have quite a diverse range of clients across the UK and actually parts of Europe as well, with across almost every single industry. So we're very good at putting together consortiums for various different innovation projects or potential grant funds. We do a lot of networking and collaboration, and also we do a lot of investor networks and putting the right people in front of the right investors as well. And the last one is kind of related to the investor readiness side. We dabble in a lot of in this side in technical due diligence. So we work with investors to try and also companies who are looking for investment to help put together pitch decks, reviews, and help them prepare for EIS, SEIS applications, but then also look at the technical due diligence of their intellectual property and also of their technology as well. So if you look at all those things, we kind of think of those things as like grant funding, R&D tax credits, and IP as kind of the holy trinity of innovation lifecycle funding. If you can get money to innovate in the first place, be rewarded for the money that you've already spent on innovation, and then ultimately create valuable IP, which then ultimately generates more value, whether it be from an investment potential or from tax credits, then again, you're really much covering the full breadth of potential innovation funding and optimizing innovation funding, as it were. So that's what we do. That's what we help with, and that's a boring bit. And again, we feel free to contact us at any time if you have any questions associated with any of this stuff. But for the purposes of this morning's seminar, I'm going to hand over to Mia, who's very much the brains of the operation. He's going to go into quite a lot of detail, specifically around IETF, which is one of the grant funds that are currently available, particularly associated with helping companies move to net zero, decarbonize, and just overall improve energy efficiency.
So I think, firstly, just in terms of a quick overview of what we're going to talk about today, we're primarily tailored towards UK-based organisations today. That can be large or small organisations, so SMEs and large companies, looking to explore emissions and energy reduction initiatives and projects. That's the focus of today. Firstly, we'll take a general look at the grant funding landscape and what's available at the moment, just by way of example. Sector-specific type grants, that they are examples. There'll be others come along as the year progresses, obviously. So it's a living sort of workspace. Secondly, we will do the detail section with Amir on the IETF, which will be of most focus today, the particularly important part. Thirdly, we will touch on some of the tax incentives and other funding mechanisms that can be used to support an IETF project and de-risk it. And then lastly, but by no means least, of course, we'll hand over to Toby and David at IPG, and they'll give you a really good example of their technology, which can be used as an enabler for an IETF project. Purposely included quite a bit of detail in these slides, as they're quite wordy, but it's so we can hand them out afterwards and you can take a look at your own leisure afterwards, and it hopefully stimulates some questions. But please, as George said, feel free to ask questions at the end, etc. So with that said, what we'll do is we'll start with the sort of grant funding taster and just a look at the wider landscape at the moment and what might be available from a sector-specific perspective. So general options wise, there we go. So generally speaking, any emissions oriented projects, as we're talking about there, anything you might be looking to do to change components or ingredients, or reduce energy, or undertake any kind of research or investigation, innovation, R&D, etc., should be looking at grant funding options and what might be available. There's a broad landscape with lots of different options. That said, grants are not just for funding. They can be used to stimulate relationships between various different parts of the supply chain, and they can be used to generate meaningful relationships. They can be used as a stimulus to support those kind of relationships. So funding is only one component part of it. Typically, in the grant funding projects that are available at the moment, you'd be looking at something in the region of 30 to 70% intervention. So 30 to 70% of your project costs for a qualifying project being covered by a grant available through one of the major grant funding organisations. Innovate UK is just one. There are others, but we're focused on some of the Innovate UK funds made available by Innovate UK, as well as those that are managed by Innovate UK below. As I mentioned, grant funding is an enabler for de-risking projects, but also enables you to extend the scope of a project. So something you thought might be a small project, maybe only a few tens of thousands of pounds, the potential is that you can grow it into something much more meaningful, engage with other partners, basically. That's the real meaning of what grants are supposed to do for you. Top of the tree, the most widely available grant funding program is Innovate UK's Smart Grants program. Provides funding support, as it says there, for game-changing and commercially viable R&D innovations. So very much at the innovation end of the spectrum, the R&D end of the spectrum, and something which has to be a groundbreaking piece of innovation. It's the most difficult to access smart grants, but it's the most it's the broadest in coverage, basically. So chances of success with that, these are all by application, deadline-driven applications. Chances of success with the UK Smart Grant tend to be relatively low, but for the right type of project with the right kind of innovation and environment and emissions and net zero type projects tend to focus quite highly, feature quite highly on their spectrum, can be exactly the right type of thing. I'm just going to run through these relatively quickly because there's lots more detail behind all of these. I don't want to bore you all with the details of each of these grant programs today. We can talk about anything that might be relevant at a later point. So the second one on the list is again a sector specific. So if you're involved in this type of area, which some of you may be, supply chain innovations related to rare earth materials, focused particularly around that technology, new and alternative materials, as it says, substituting, reducing the amount or the energy that's consumed in extracting rare earth materials, rare earth metals. Something along those lines for battery technologies, or anybody engaged in a battery technology project, for example, would be suitable for something like that. And there are very significant amounts of money available for those type of projects. More broadly speaking, we're looking into the automotive sector, anybody engaged in companies currently working in the automotive sector, anybody within the supply chain. The Advanced Propulsion Centre runs a series of grants during the course of the year. They're very significant amounts of funding. The applications can be quite significant in terms of their size, but it's worthwhile getting involved in the strategy and understanding what the long-term opportunities are with looking at APC, because there are significant amounts of funding. It can build very, very good relationships with the automotive sector and the automotive supply chain, collaborative R&D projects in particular, and tend to be focused around low carbon automotive technologies. So again, just another example of a sector specific grant that's currently available, and on a rolling basis, APC makes grants available. ATI is looking at the aerospace side of things. So automotive we've done, aerospace is covered by ATI, which is the Aerospace Technology Institute. Again, very significant amounts of funding available, can be looked at from a funding strategy perspective. Again, long-term funding strategy perspectives are the best way to look at grants and how they can enable your business. Specifically adapted for the aerospace sector, obviously, helps to develop relationships, helps to stimulate and engage with the aerospace sector if you're looking to get involved with aerospace. Or have something which you think may be suitable for the aerospace sector. It can help to drive relationships, build relationships, and also support. It provides funding to support any kind of project in that space. Next up is Eureka Collaborative R&D. It's broadly speaking, it's an innovation project creation application process. It's a rolling program. We mentioned that because it's available on a rolling basis. So again, worth looking at. It's just another option, another tool in the toolbox, basically, if you want any further information on that. Again, there are lots of details associated with it. Innovation loans is, it may sound like a less viable subject if it says loan in the title rather than grant, but actually these are very preferential loans made available via Innovate UK. It's been a very successful program. Again, can be millions of pounds available in this space. They can be very suitable for projects, enabling you to grow projects, support projects. And the benefit of the innovation loan program is that those applications tend to be more successful than, let's say, its comparator to the Innovate UK Smart Grant program. So if you're looking for funding for a project on a very preferential basis and you don't mind going down the loan route, then innovation loans are definitely worth considering. Lastly, on the list is the Industrial Energy Transformation Fund, which is actually a project which is a program which is funded by DESNZ, and that's what we're going to be covering in detail on the next few slides, probably the most relevant to today's conversation. So the last of the options. So we'll turn to that now, and Amir will cover that now.
Hello, everyone. IETF stands for Industrial Energy Transformation Fund, as James mentioned earlier. This is the program that one of the departments of government, which is focused on net zero, is funding. This year it is one of the biggest budgets for innovation, but the innovation is more focused on practical rather than research and development, so higher TRL. I'll go through that in the next slide. But the main objectives of the program are threefold: reducing industrial energy demand, reducing industrial emissions, and de-risking the market for decarbonization technologies. So the industrial processes that are covered through this program are as below: mining and quarrying, manufacturing, recovering and recycling of materials, data centers, industrial laundries, and controlled environmental horticulture, which we believe the companies under BCF are qualified as long as they are they fall in within one of those categories. The program comes in two sub-phases this year. The first one is which is the spring 2024, already rolled out, and the applications are open for submission. The deadline is 19th of April, and it covers two main strands. One is the studies, the other one is deployment. Studies comes in two sub strands, which is feasibility and engineering, which I will take you through that in later slides. The second sub-phase is summer 2024, which the applications open in June, July, no exact date yet announced, and the deadline would be in September. And the budget for the whole year of this phase is £185 million. So the reason that I mentioned that IETF is not mainly or purely R&D, research and development focused, so like the other examples that James mentioned earlier, is that because it's focusing on very high TRL technologies. These are technologies that are TRL 7 and above, which means that they have at least have had a prototype demonstrated in an operational environment. So any technology that you would consider should be TRL 7 and above. And what's interesting here that they have this year, because this is the third phase, there has been two other phases previously. They have added technologies that enable the use of recovered waste heat in heat networks, and space heating are in the scope, which are in addition to a primary industrial use case for that. So that's something interesting that you can now consider in your application and for funding from the government. Collaboration is allowed in these projects or in this sort of funding, and it is quite actually supported and promoted, because you would see that you would get further uplift in the intervention from government. But your collaborator should be a business of any size, or a research organization, or an RTO. RTO stands for Research and Technology Organization. These are defined by the government, and or an academic institution, or a charity or public sector organization. Be registered in England, Wales, Scotland, or Northern Ireland, but the work should carry out in relation to a site or a factory located in England, Wales, or Northern Ireland, not Scotland. So the company, even the company that applies, the lead partner or your company can be also registered in Scotland, but the work has to happen in for the site, or the project should focus on a site or a factory within England, Wales, or Northern Ireland. And if the factory or site is in Scotland, is out of the scope. Right. So I mentioned that there are two major strands within this program. One is studies. And under the studies, we have feasibility and engineering studies. Feasibility studies are the ones that are is to investigate technical, economic, and operational for deploying technologies and solutions in an on an industrial process in a site. What has been added to this phase is that you can you can propose in your application for analysis of various different technologies and solution, provided these are intended to deliver the same outcomes for a site. So you can actually look at different technologies and analyze them and to come to a decision that which one is the right for you to deploy. So that is also considered as eligible within this phase of the program. Engineering studies are mainly focused on basically front-end engineering and design. And you have to through that you should develop a detailed project plan and identify a specific technical and operational requirement. The funding available for feasibility is minimum 30K of total cost. So your project should be minimum 30K, and the maximum threshold is 7 million total grant. So, and you would see in the you can see that the funding intervention rate is different for different size of the companies, but that's 50% for large, 60% for medium, 70% for small or micro. So that means that 70 million should relate to that sort of percentage funding, and that's the maximum threshold you can apply for. Engineering studies, 50K total cost, minimum threshold, that's total cost of the project, and the maximum is 14 million total grant. And the intervention rates are lower than the feasibility, and it starts from 25% for large, 35% for medium, and 45% for small and micro. As you can see, there is a 15% uplift available if you are if the project is an effective collaboration. What that means is that you have a project partner that share the costs, share the risks, and they also claim funding through the program. So they get funded based on the size of their company. So that means effective collaboration. On that basis, you can ask for extra 15% uplift. Right. So deployment programs. So the energy. So deployment programs are also, our scheme is divided into two, which is energy efficiency and decarbonization. Energy efficiency deployment is focused on reducing the energy consumed by industrial processes at site level or factory level, which attributes to benefits in both savings in the bills and any associated emissions savings, which is sometimes you get the emission savings, sometimes not. But as long as you reduce your energy consumption and reducing your bill, that is within the scope. The examples of such projects or technologies that you can consider in this scheme or strand is process optimization, equipment upgrade, process heat and energy recovery systems and heat pumps, resource efficiency measures. I think resource efficiency measures are like measures to reduce wastage and optimize use of raw materials that result in lower on-site energy consumption. Minimum threshold is 100K total grant for large companies and 75K total grant SMEs. So there's a different. This is a change from last year. So they have reduced the minimum threshold to 75K for SMEs to make it more viable for them. Maximum threshold is 14 million total grant, and the funding available is 30% for large, 40% for medium, 50% for small or micro. There will be 15% uplift available, based up to 15%, based on where your site or factory is located. And if it is located in a less economic advantage area, then you can claim more funding, but that would be up to a maximum extra of 15%. Right, decarbonization is another subcategory of this strand or scheme, which is to reduce the emissions produced by industrial processes at site or factory level. While in some cases there may be an associated energy saving, this is not the key driver for the project. So it's important that when you look at which scheme is you are qualified for, is you have to really see what is the main driver for your project. Is it decarbonization or is it energy saving? Examples of decarbonization projects are fuel switching. For example, electrifying your industrial process, or using hydrogen or hydrogen blend as fuel, or use gas, biomass, biogas, and waste fuels as an alternative to what you are using now, and it provides you with less emission in overall. On-site carbon capture technology for utilization or storage as well is counted towards this category of funding. Minimum threshold, same as the energy efficiency, 100K total grant for large companies, 75K total grant for SMEs, but the maximum threshold is 13 million total grant, so it's much bigger. You can go for much bigger projects here, and the funding level is also higher. 50% for large, 60% for medium, 70% for small, and you can claim for 15% extra funding based on where your site or factory is located and whether it is in the disadvantaged area or not. So I'm just giving you some examples here from previous phase, just to that you could see what type of projects are sort of very successful. It's just I thought the first two case studies are, as far as I understand, they are also members of BCF, and the last one is, I think, is just relevant. So the first one is Innovate UK Ltd. They applied for deep decarbonization deployment strand, and the project was a steam boiler project, hydrogen fuel. The project was 4.3 million, and the grant offered to them was 2.6 million. I just go through this a bit quicker. We will share the slides, so you will have a chance to read the project abstract basically there. The second one is Venator Materials UK Ltd. They went for engineering study. Is the other strand of the program, and the project was hydrogen infrastructure feed, which is front end engineering design study at Venator Gretham. The total project was 276,000, and the grant offered was 69,000 to them. The last example from last phase was Mitsubishi Chemical UK Limited, and the project was energy efficiency deployment, and the project cost was 9 million, and the IETF grant offered was 3.1 million. And the project was to install a thermal oxidizer with waste recovery boiler for energy efficiency and emissions reduction. I think that's it from the program. Just to say that one more point that you may want to know: if you apply, there are two, as I mentioned, there are two deadlines this year to apply. One is in April, one is going to be in September. And the expectation is that if you apply in the first part of this year, the expectation is that you would start the project in the first quarter of 2025. And if you start the second, if you apply for the second part of this year, then the expectation is that you would start a project about in Q3 of 2025. So just to let you know that the time between application and when the expectation is the project to start, and the project is expected, the projects can go up to towards the end of 2028. So it's about just less than 3 years. So that's it for me.
Okay, so I think I'll run through these relatively quickly and we get on to IPG. So just to say that on top of support available through the grant funding regimes to support innovation projects in the areas that we've just talked about, there are other incentives and support measures which can help to de-risk and maybe help to extend the scope of a project or get it signed off or bring it forward more quickly or things of that sort. And those are some things that you will be familiar with already, obviously. So I suppose many of you will already be very well aware of the R&D tax regimes. There's lots of talk about that in the press over the course of the last year or so for various different reasons because things are changing, but it's very well known. But particularly in the context of an IETF grant, for example, the main message here is that it's still possible to utilize other incentives to de-risk and offset the costs of a project and, as I say, potentially accelerate it, things of that sort. And it's not always well known that grant-funded projects can still be supported with other incentives of this type, so tax incentives, etc. as well. The other point I would mention about this slide is that critically, whilst the names of these incentives, so R&D tax and the patent box regime, they sound very tax focused and it sounds like an accounting exercise. In reality, they're founded in a sort of solid scientific and engineering assessment of the activities that are being undertaken, and that's the best way to get the most from these regimes. It's not really a numbers game, it's more of an engineering and scientific assessment. Hence why we're all engineers and scientists by background, actually, because when we work in this space. So first on the list, just covering relatively quickly on the R&D tax credit side of things. Large companies can effectively recover something in the region of up to 20%, depends on the year actually, up to 20% of the qualifying cost of their R&D activities, which could, for example, be part of a project which is supported by an IETF grant. Again, a scientific and engineering assessment can bring a far broader range of activities and costs into scope. And this can ultimately be a very, very supportive measure to bring down the risks and the costs associated with a project. The schemes will be combined from 2024, so there are some changes associated with the two different regimes. So there's a scheme for SMEs and also a scheme for large companies at the moment. Lots of change in the space, and it's best to talk about that on a case-by-case basis. But you can see the rough facts there of what can be obtained, and you can see that for both SMEs and large companies, the benefit can be very significant for the right type of project and if assessed in the right kind of way. So a proper engineering analysis would be advised in that space, if considering any kind of innovation project, not just those linked to an IETF grant. Lastly on the list here is the patent box regime, which is by far the lesser known and less well accessed of any of these regimes, but is has particularly grown in value as a result of the corporation tax rate going up last year. So it enables applicants to benefit from an effective rate of corporation tax payable on profits derived from the exploitation of IP of 10% rather than the 25% rate. So if you are a tax-paying organisation, this can make a very significant difference. And obviously, what we would expect would be that an IETF project or other innovation project would lead to the generation of, let's say, new products, new processes. Let's say we're removing or replacing or substituting ingredients or component parts of processes and end products, making them more friendly, or there's a mechanism for making those processes more energy efficient that leads to a major change. patentability in that space is strong and can be easier to access than you might imagine. They don't have to be very, very expensive, extensive patenting regimes that can be strategically done quite effectively on a relatively small budget to access the patent box regime and access that 10% rate. It can be a complex regime, patent box, but it's well worth looking at if the prospect is that there's going to be any innovation involved in one of these projects that you might be engaged in. Well worth looking at, as I say, because it's grown significantly in value over the course of the last year or so. So that's it, just by way of recap of those supporting activities. And then what I'll do is I'll hand over to Toby and David, who'll be able to take you through these slides on IPG.
Good morning. IPG Photonics is the world's largest supplier of industrial lasers. We've seen a high growth in our portfolio of late for sustainable solutions related to laser cleaning, and particularly we'll talk about today of laser heating, drying, and curing, particularly of industrial coatings. I'm Toby Streit. I'm helping roll out this technology, and also present is David Goodwin, our MD for the UK. So how does a laser oven work? Well, we're particularly targeting replacing hot furnaces of all types with cold furnaces, and that's an intriguing notion. Essentially, the animation is not running, so maybe click again. There we go. So, so convection furnaces, we all, let's go back.
Yeah, it ran, Toby, and then it stopped running. Sorry, I don't know why it's doing that.
Yeah. If you go down the lower left, you can start the animation again, or I can share it on my screen if it's easier. Why don't I switch gears and share my screen?
Oh, there we go. It's come up. The thing's come up actually. There you go. There you go.
You can take control as well, Toby, if that's
lovely.
Easier.
Okay, so essentially convection ovens are rather slow. A laser is able to penetrate a coating and have a volumetric drying process. It's essentially the analog of a microwave oven in your kitchen. The result is we've demonstrated drying time reductions that are quite huge. The laser's enormously efficient, largely because it's not heating your factory, and very good at delivering energy to the product. And because the furnace operates in a cold mode, you can put all sorts of instruments in. So our customers have identified numerous opportunities for sustainability based around these basic parameters. Next slide, if you would. This is what the oven looks like in one of our application labs. So you see a cabinet on the upper left. There's really no walls required. The laser doesn't heat the air as it passes through. It delivers all the energy onto whatever pattern we wish to project. Below you see a 1.3 meter by 30 centimeter pattern for this particular laser. In the upper center, you see a projection head that's positioned about 1 meter above the product. And behind it is a FLIR IR camera, which is a good example of the sorts of metrology that we're able to use to control the process precisely while considerably speeding it up. Because this furnace isn't hot per se, it considerably simplifies the infrastructure of the furnace and clearly does not radiate very much waste heat into the factory. It's also a digital furnace, which is on and off like a light switch. So if you're running a batch process, you never need idle, and certainly not overnight. The accessibility of the furnace is also an advantage. We've routinely introduced numerous metrology into our processes. Next slide. So an example relevant to this audience is curing powder coat on steel. We introduced this and published this about 9 months ago. So essentially, you can see that a powder coat curing process can be reduced to less than 1 minute on powder that the manufacturer would advise takes a 10-minute cure at 400 F. Mainly because the laser is imparting all the heat to the coating and very little to the substrate. Of interest is coating materials that don't necessarily want to have a lot of heat in the substrate. As you can see, the coating, while applied extremely quickly and cured, is also of a very high quality. So all the standard ASTM tests are passed in this case. And just to wrap up, there's really 6 advantages of replacing a conventional oven with a cold laser oven. Clearly, the accelerated speeds, as well as the additional monitoring, the energy savings is quite significant because the process is so quick, and the lasers require very little maintenance. They're quite a mature product. Really, we've been focusing lasers for 35 years. Only 18 months ago, we learned that we could project them as well. And finally, the obvious improvements to the factory environment of having a cold oven. And since the process is so quick, these ovens are also quite a bit more compact than previously conceived. So with that, I'm open to any questions you may have.
Yeah, great. I think from all sides, that's us done, I think. And if there's any questions immediately, we can myself or Toby or Amir, we can take them now, or say we're happy to field questions after the event. We'll send the slides out, and you'll have our direct emails to ask us anything specific project-wise. But if there's anything in the interim that anybody would like to ask, we're happy to answer.
We will share the slides with you, and obviously you can always contact us offline as well if you have more detailed questions and you need you need us to clarify something for you. More than happy to do that.
Question: how does laser curing compare to e-beam technology in terms of cost? This is a question for Toby.
Asking which application?
I'm not sure either.
Yeah, so e-beam, I'm not familiar with.
In terms of coating curing.
I haven't come across e-beam technology very much. We've mainly been displacing infrared lamp with very similar dynamics, except for the lack of heat in the oven, and traditional carbon, generating convection like gas-fired. We haven't really come across e-beam. We don't need a vacuum, which is generally one of the drawbacks of e-beam technology. We've cured a wide variety of coatings and dried paint as well. So all the way up to porcelain enamel at 800 Celsius, down to very gentle drying of paints right around the boiling point of water.
Yeah, I just want to say a big thank you to the Think Incentives team and IPG as well for their presentations. So yeah, as we said, we'll share the slides and the recording with all your contact details in case of members having any further queries or questions. So if there isn't anything else, I guess we can just close session.
Thank you very much.
Okay.
Thank you.
Thanks very much.
Thanks a lot.
Thanks,
Have
Toby.
a good day.
Speak soon.
Thank you.
Bye.
Bye.
Bye.